Hello everyone! In power electronics, isolated gate drivers are used to drive power semiconductors like IGBT and power MOSFETs. The gate drivers are used to provide galvanic insulation between the control circuits and the high voltages. They are also used for level shifting to provide high gate voltage and current to switch the IGBT or MOSFET. In industrial applications like inverters and motor drives, EMI noise will be generated by an inductive load-like motor. The noise may cause reflection, resonance, or amplification within the gate drivers inside the power electronic equipment by its coupling through the wirings. This will cause the gate drivers to malfunction with erroneous output and, worse, permanently damaged. To meet stringent requirements for functional safety in motor drives and inverters, it is very important for the gate drivers to be immune to the EMI noise. Today's available galvanic isolated gate drivers use three different types of coupling, namely capacitive, magnetic, and light for signal transmission across isolation barriers. We're going to use an impulse noise simulator to create EMI noise to see how it affects these three different couplings. To generate the EMI noise, we use a Noisecon INS 4020 impulse noise simulator. We will vary the impulse noise from 500 volts to 2000 volts with 50 nanoseconds pulse width. A 10 kHz and 50 microsecond signal will be sent to the inputs of the gate drivers under test. An oscilloscope will be used to measure the integrity of the signal transmitted across the different galvanic couplings of capacitive, magnetic, and light. We will use missing pulse with more than 60 microsecond at the gate drive output to determine if the transmission has been corrupted. The first gate drive we're going to test is OnSIM's NCD 57001, which uses capacitive coupling. It is a 16 pins gate driver with a DSAT protection feature. The OnSIMI gate driver is failing as there are missing output pulses when 600 volts periodic impulse noise is introduced on the surface of the gate driver's package. The second gate drive we're going to test is Analog Devices ADU-M 4136, which uses chip-scale transformers to provide isolated communication across the galvanic isolation. It also has integrated DSAT detection to protect against short-circuit IGBT operation. The ADI gate driver output latches when negative 1100 volts periodic impulse noise is introduced on the surface of the gate driver's package. When latched, the driver is drawing excessive current and is permanently damaged. Next, we're going to test Infineon's 1ED020L12F, one of the ICE drivers which uses coreless transformers to provide isolated communication across the galvanic isolation. The device uses an IGBT desaturation protection with a fault status output. The Infineon gate driver has missing output pulses when 1200 volts periodic impulse noise is introduced on the surface of the gate driver's package. Next, we're going to test Texas Instruments ISO 5851, which uses capacitive silicon dioxide isolation core to couple signal across the isolation barrier. The power stage consists of DSAT detection security to monitor the IGBT collector-emitter overvoltage. The TI gate driver has missing output pulses when negative 1200 volts periodic impulse noise is introduced on the surface of the gate driver's package. The next gate driver we're going to test is Silicon Labs SI8285, which uses an RF transmitter and receiver to couple the signal over the semiconductor-based isolation barrier. It has a DSAT pin to detect the desaturation and shuts down the driver in a controlled manner. The SiLabs gate driver is good and does not have any missing output pulses. However, when impulse noise is increased to negative 1900 volts, the output latched. When latched, the driver is drawing excessive current and is permanently damaged. The last driver we're going to test is Broadcom's ACPL352J. This is a gate drive optocoupler, which uses light to couple the signal across the reinforced isolation barrier. The ACPL352J is a 16-pin driver with integrated overcurrent protection. The Broadcom gate driver is good and does not latch or have any missing output pulse at the impulse noise generator's highest rating of 2000 volts. I hope this helps in your selection of isolated gate driver and coupling technology to achieve the highest immunity to EMI noise. Share your experience. Do you see what I see? Leave a comment here.